Okay, now our data has been transformed or changed from the wide form to the long form. Now let's proceed to our analysis of our generalized estimating equation or longitudinal data analysis. So click on analyze and go to the generalized generalized linear models, and then finally the generalized estimating equation is here. So click over there. So here what we are going to do is uh, the within subject variables and the subject variables. So the subject variables, as I have shown you there in the PowerPoint, there's a procedure over here which is written over here. What we are going to do is the repeated measurement will be entered into the subject's variable. So the subject variable should be entered into the subject window. And here again we need to select the working correlation structure. You see? Let me go back to the SPSS. So that means here we do have the subject variable. So that I need to put this in the subject's variable window over here. And over here there's the one which says structure. If you click over here, there are those 5 working correlation structures: the independent, the autoregressive, the exchangeable, the M-dependent, and unstructured. So first we need to test the independent. Then interchangeably, step by step, we'll do that again. Okay, so we go for again the type of model. The type of model that we are going to use is the normal distribution with link function of identity, because the outcome variable is continuous. So I need to click over there by custom, click on custom, and already normal is over here and identity link function is also over here. Now we have selected our distribution, probability distribution, that is the normal distribution, because the outcome variable is continuous and the link function is identity. And then go to the response variable over here. So we need to put the response variable there in the dependent variable box. So the response variable is depression over here, the one that we have created from when we are changing from the wide to the long form. So depression should be taken to this, and then we need to go for predictors. Click over there. And the predictors are 3. I think the group is categorical, so I need to take this to the factors, and by clicking on the option I need to select the descending one, that is the placebo group, should be the reference group, and then continue. Okay, the remaining 2, the pre and the visit, the pre-trial score of depression and the time are continuous variables, so I need to take them in the covariate box. Okay, click on the model again over here. I need to select all these predictor variables and take to the model box and check that this main effect is selected. Estimation method, we are not going to do anything, and the statistics, what we are going to do is the working correlation matrix. In order to see the correlation coefficients, we can check this working correlation matrix, we can see. And if we are interested to report the beta coefficients in the form of odds ratio, we can select this include exponential parameter estimate over here. So hereafter we can say or click on OK. So here is the result for the generalized linear model, that is the generalized estimating equation. So what it tells is the model information, that is the dependent variable is depression. The probability distribution is normal. That is because the outcome variable is continuous. The link function is identity. And the subject effect is subject, and the independent variables working correlation structure is independent. Okay, case processing summary, the included cases and the excluded cases, because since it's around 71 missing values are there, so they are excluded. Okay, correlated data summary, the minimum, the maximum number of measurements per subject, it will tell us over here. Categorical variable information, especially the group membership in the estrogen, that is a treatment group, the placebo group, the number of individuals with their percentage. And again, the variable information for the continuous type of variable. Depression outcome variable by itself is continuous, total number of observation, the minimum score, the maximum, the standard deviation with the mean. And for the covariate, the two predictors, covariate predictors, the pre-variable and the visit, their frequency, the minimum value, the maximum, the mean and standard deviation. So this is a descriptive result for both the continuous and that of the outcome variable. So the goodness of a test, if we are going to rely on the QYC value to choose the working correlation structure, here it is a QYC value, you know. So when you are trying the working correlation structures one by one and have a look at the difference between this QYC value, the lowest QYC value working correlation structure will be the better. That is a suggestion of some textbooks or authors. And in this example, we are not going to rely on that, you know. Okay, tests of model effects. This tells us that whether each predictor variables independently have a statistical significant association with the development of the outcome variable over a long period of time. So each of the three variables are statistically significantly associated with the development of depression during the follow-up period. That is the group, the drug, the pre-test score of depression, and then the visit, the time. So all the three predictor variables are statistically associated or significantly associated with the outcome variable. You see? Now, the last table that we are going to use for interpretation is the parameter estimates, you know? Okay, sorry. The parameter estimates. We are not interested to the intercept, but for the group 1, that means the group who is taking estrogen patch, the drug, they are less likely to develop depression in the long follow-up period of time. Beta coefficient is minus 4.29. And therefore, the odds ratio will be less than 1. So compared to those who are in the placebo group, women who are taking the estrogen patch, that is the drug, are 0.014 times less likely to develop depression in the follow-up period. So in terms of percentage, the reduction will be almost 1 minus 0.014. That is 99.6% reduction in depression, you know, which is very effective. Okay, the second one is the pre-intervention score of depression. So with a unit increase in the pre-intervention score of depression, so the probability of developing depression in the follow-up period will increase by this beta coefficient, or by this amount of odds ratio, 1.611. And the p-value is statistically significant, you know. The visits, the time itself, have again a negative beta coefficient. That means with a 1 unit increase in months or in time, the probability of developing the depression over the long period, over the follow-up period, will decrease by 1.31, you know. In terms of beta odds ratio, it will be 0.27. Or maybe in terms of percentage, it will be around 73 or 83, something like, yeah, 77. Or maybe 73, sorry. 73, because 1 minus 0.27. Or 100 minus 27 is 73. So there is a reduction of 73% with a unit increase or a 1 month increase in the visit, you know. 73% decrease in probability of developing the depression during the follow-up period. Okay, so we need to look over here the p-values of this working correlation structure, you know. The working correlation structure for this is now independent, having these p-values. Okay, if we look at the working correlation matrix, since the independent working correlation structure says that all correlations are 0, so it will be 0. Everything will be 0, except the 1 1s, you know. These 1 1s are because one will be correlated with itself. One time measurement with itself, that will be 1. Otherwise, all the correlation coefficients will be 0. So that is the independent one. So we'll go back again to change other working correlation structures. So going there again, analyze generalized linear models, generalized estimating equation. So here what we are going to do is, over there in the repeated button, we need to simply change the working correlation structure. This is independent. Now let me make auto-regressive. Since all things have been done before, I can click OK now. And the output is here. So I can have we can have a look at all the parameter estimates. All things will be more or less similar, you know. But the parameter estimates will have a p-value of maybe similar or different from the previous one. So for beta, for intercept, for the group membership, for the pre, and for the visit, all the p-values are being given here. And the working correlation matrix, if you have an interest to see over here, because it assumes that as time goes on, the correlation coefficient will decrease. For example, let's have a look over here. Between 1 and 1, since it is correlated with itself, it will be 1. Between 1 and 2, it will be 0.69. Okay, between 1 and 3, it will be 0.48. Between 1 and 4, it will be 0.334. You see, it is getting smaller and smaller and smaller as time goes on. That is the autoregressive working correlation structure, how it does this, you know. Now, let's try another working correlation structure, which is again being there in the repeated button. Let me change the exchangeable one, exchangeable, and then click OK. And then let's go to the parameter estimate and have a look at all the p-values, you know. And this has been, this is already what written in there in the PowerPoint. And you can have also an appreciation of the working correlation matrix, how it differs. Okay, and again, going back to the analyze and generalized linear models and GEE, we can also change this M dependent. Okay, M dependent. After choosing this M dependent, I need to specify the value of M, either 2 or 3 or whatever. So let me put, for example, 3, and then click OK. Now, the p-values are over here, and you can see the working correlation structure. And going back to again analyze generalized estimating equation GEE, and then the last one is you know, unstructured one. So all correlation coefficients will be different according to this. Now click on OK, and you can have a look at over this, and then you will compare the parameter estimate table for all these 5 types of working correlation structures. The one with the better p-value will be taken as a better working correlation structure. So this is the way how we can do longitudinal data analysis or generalized estimating equation for a continuous type of outcome variable.